Today we're going to discuss how to do the calculations of your Hydrate lab, where you heated up 4 different substances in a test tube and watched as water evaporated out of those hydrates. And you need to calculate a couple of different things, including the percent of water and also an empirical formula of test tube number 4. I'm going to take some sample data for test tube number 4 and just show you how to do the calculations for number 4, which will include also the same type of calculations for test tubes 1, 2, and 3. Let's recall what we did. You heated up a test tube. First you weighed the test tube by itself. So here's the test tube by itself. Then you put the hydrate in the test tube. And then you heated up the test tube on a Bunsen burner. And when you heated up the test tube, the water went away. And then you were left with just, in the end, the salt. So you had a hydrate in the second weighing and a salt in the third weighing, and between the second and the third weighings, the water went away. Okay, so if we're going to call this weighing number 1, weighing number 2, and weighing number 3. Let's suppose we want to find the mass of the hydrate in the test tube before heating. Well, the hydrate is located in test tube number 2, and to get it by itself, you need to take measurement number 2 minus measurement number 1. So measurement number 2 minus measurement number 1, in this case, for me, is going to be 19.37 grams minus 17.01 grams. And that's going to be 2.36 grams of hydrate in the 4th test tube in my case. All right, in the next calculation, you want to find out the mass of water. So the water is the difference between weighing number 2 and weighing number 3. Because in weighing number 2, you had a hydrate, which is salt plus water. And in number 3, you only had the salt because the water went away. So you will notice that weighing number 2 is a larger number than weighing number 3 because you got rid of the water. So I'm going to take weighing number 2 minus 3. So weighing number 2 minus weighing number 3. That's 1937 minus 1820 for me. So 1937 minus 1820. And that's going to be 1.17 grams of water that were in my test tube number 4. And now we want to find the percent of water. Well, the percent of water is the mass of water over the mass of the hydrate times 100. So look, you just found the mass of water, which was 1.17 grams of water. Just neaten this up a little bit. And then you want to divide that by the grams of the hydrate, which we found on the first page, which was 2.36. So 2.36 grams of hydrate times 100. When you do that math, I'm going to get, with 3 sig figs, 49.6% water. That's a pretty high percentage, almost half. Almost half of that hydrate was water. Okay, now, remember when I say percent, you say grams. So we did this calculation in grams. However, when I say formula, you say moles. So since we're trying to get a formula of the last hydrate, in other words, we know it's MgSO4 dot something H2O. That's a mole ratio, and so I need to get in moles. So what I need to know is the moles of water, and I need to know the moles of salt. So the moles of water. Well, I know the grams of water right here, 1.17 grams. So I just take 1.17 grams of water, and I want to convert that from grams into moles. Now water you have to add up from the periodic table. So you have 2 times 1 plus 16 is 18.0. So 1.17 divided by 18 gives you 0.065. 0.065 moles of water in the hydrate. So in my 4th test tube, this is how many moles of water came out. Now I need to know the moles of salt. Well, the salt is the MgSO4. MgSO4. Now, I never figured out how much salt was in test tube number 4. But what I do know is that I have this much hydrate and I have this much water. So since a hydrate is salt plus water. So hydrate is salt plus water. And I know that my hydrate is 1.17, hydrate is 2.36 grams. So my hydrate is 2.36 grams, and my water was 1.17 grams. All I have to do is subtract those two numbers, and I'm going to get the salt, which is 1.19. So that means I have 1.19 grams of salt, which is the MgSO4. So 1.19 grams of salt, and now I have to convert grams into moles. So I have to add this all up from the periodic table. So Mg is 24.3 plus sulfur, which is 32.1, plus 4 O's, which is 4 times 16, or 64. And the whole thing weighs 120.4. So now I can get my moles. 1.19 divided by 120.4 is going to give me 0.00988. 0.00988 moles of MgSO4. So these are not really that easy of numbers to work with. Okay, we have 0.065 and 0.0098, and those are not easy numbers, so we want to change it into a very simple ratio. So we basically want to divide the bigger number by the smaller number. So if I take my 0.065 moles of water, I know that that went with 0.00988 of MgSO4. And now I'm just going to divide those two. 0.065 divided by 0.00988. That gives me a 6.6 ratio, 6.58. All right. So 6.58. I'm going to round that to the nearest whole number, so that's going to be a 7. So what that means is that the answer for my hydrate would be MgSO4.7H2O, according to these results, which actually is the right real-life answer. But if yours doesn't come out to be a 7, if yours comes out to be a 6 or a 5, you would write that number right here, and that would be fine, because that's your data. Okay, lastly, for the data analysis, you'll be able to figure this out yourself. Which of the substances were hydrates, and what evidence do you have to support your answer? One of these test tubes was not like the other, in the words of Sesame Street. So there was one of these 4 test tubes that was not the same as all the others, and you visually saw a difference. You could see a difference in the formulas. You saw a difference in how the masses changed over here, or perhaps did not change. So I'm going to leave that up to you to figure out which ones were hydrates and which ones were not. And then you're going to write a simple equation for the ones that were hydrates. So only for the hydrates are you going to write this equation. You're going to write the formula of the hydrate. So for this one, you would write MgSO4.7H2O, or whatever you got. Solid, that's the S, plus heat. The arrow means yields. And then you would write the salt separated from the water. So the salt by itself, solid, plus all the waters, gas, because they became steam. So you're just taking the hydrate together, plus heat, yields salt separate, plus water separate. The salt is solid, the water is gas.